Good afternoon, my dear student. In the previous day, we discussed about the thermodynamics and specifically the Gibbs free energy and the spontaneity of the reaction, the chemical reaction. Now, today we'll discuss about another new topic which is also included in the thermodynamics. This is the part of the thermodynamics, which is electrochemistry. So, from the topic electrochemistry, that is, there will be electro, that is the involvement of electron, and the chemistry is related to the electron. So, that's why it is electrochemistry. And student, you have already known that it is your in syllabus, and you are looking here the example of a galvanic cell, and you have already know that I am Dr. Vishwajit Gain, the assistant professor, Department of Chemistry from your college, Dr. Sudhir Chandrasoor Institute of Technology and Sports Complex. Sorry, there is a missing of complex, but the full name Dr. Sudhir Chandrasoor Institute of Technology and Sports Complex. Now, before going to the details of the electrochemistry, we need some information or some knowledge about oxidation reduction reaction, that is redox reaction. So we have already known that the oxidation reaction means loss of electron and reduction means gain of electron. So in electrochemistry, that is loss and gain and other thing, that is transfer of the electron, is very important in electrochemistry. So basically in electrochemistry, yes, obviously there will be a transfer of the electron from one end to the another end, or movement of the electron, but these free electrons are coming as a result of oxidation and reduction. And you know that oxidation reduction takes place for a particular chemical or in a chemical reaction. So by means of the chemical reaction, we can get some electron, and there will be other system in the combined system where it will be accept electron. So totally there will be a transfer of electron. So very specifically we can say that electrochemistry is the study of chemical process that cause electron to move. I have already told you this movement of electron is called electricity. Yes, it is the part of the electricity which can be generated by movement of electron from one element to the another element. Yes, obviously one element to the another element, but here the reaction is involved, or the chemical reaction is involved. Reaction known as the redox reaction, and as a result of the redox reaction, we get some electron, free electron, and the free electron move, and we will get the electricity. In this type of the cell, that is in galvanic cell, here two electrode, because if a question of the cell, then there is a question of the electrode and solution and the other chemical reaction. So here in this basically galvanic cell, there will be two electrode, one is the anode, another is the cathode. So student, please note it and you will remember it, that oxidation takes place in anode, and here that is excess of electron. That's all, and I will discuss the detail later. So in another thing, that is in cathode. So here reduction occurs, so it accept electron, there will be some of the positive sign, that is it it can have an ability to absorb electron or gain electron. So very simply, here in galvanic cell, the oxidation take place at anode and reduction take place at cathode. So what are you thinking? You are thinking what are happening and other thing, but I'm saying that the majority of the chemical reaction can be classified as one or two major category. Number one is very simple, that is acid base reaction, where the transfer of the proton is the main criteria. So in acid base reaction, transfer of the proton play an important role. Now in case of the redox reaction, we are not the proton involved but direct electron are involved. So in redox reaction, electron plays an important role. So if I take a simple example, the redox reaction here, if you look the reaction, that is Fe3 plus V2 plus is converted to Fe2 plus, sorry there is a missing of the plus sign, and plus V3 plus. So here the ferric ion is converted to the ferrous ion, so there is the involvement of the reduction, and V2 plus is converted to the V3 plus, so there is a oxidation takes place. So the first reaction, that is Fe3 to Fe2, is an example of the reduction reaction, and Fe3 is acts as a oxidizing agent. And on the other hand, V2 plus 2 to V3 plus 3, oxidation takes place, so V2 is an reducing agent. Now we are coming to the real problem, that is voltaic cell. Electrochemical cell that use an oxidation reduction reaction, electrochemical cell that use an oxidation reduction reaction and generate an electric current are known as galvanic or voltaic cell. So in case of the voltaic cell, by means of the chemical reaction, we can get electricity. So, and another thing, that is electrolysis. So electrolytic cell, there the opposite thing is happening. By we are sending some electricity to the solution, and the opposite reaction of the galvanic cell will be happen. So both are different. So one case, in galvanic cell electricity is generated, and electrolysis electricity is responsible for the chemical reaction, and here chemical reaction produce electricity. So huge difference between the two things. So now if you look into the picture, so okay, I'll discuss in later. Okay, if you think, so there is a zinc electrode, and there is a hydrogen electrode. So if you think about the zinc electrode, this is acts as a anode, and it is oxidized, so it is converted to the Zn2 plus. So there will be excess of electron, and that excess of the electron will go through the air, and it show deflection of the voltmeter. And on the other hand, there will be a hydrogen plus or acidic solution, and that hydrogen plus reach to the electrode, that is platinum electrode here. The hydrogen electrode is combined with the platinum electrode, and it accept electron. Yes, student, there is a mistake in this reaction. Basically, here H plus come to the electrode, that is cathode, and it absorb electron, that is from the cathode, and it become hydrogen atom, or ultimately when the two H plus come and accept two electron, that is reduction takes place, then it will be acts as a it produce hydrogen. So basically here in the left hand side, zinc converted to the Zn2 plus, and here H plus, that is acidic solution, is converted to the hydrogen. So this is the reaction, and by due to these two reaction, there is a transfer of electron from anode to cathode, and this solution, two solution or the two chamber are different. It is connected by to take the neutrality or make the neutrality by using salt bridge. Here the salt bridge, the salt bridges are mainly formed by the solution or agar solution, or it is jelly material by KCl, KNO3, etc. So it keeps the maintenance of the electron balance in cathode and anode, that is in chamber. So now if you look here the total reaction, so then you will see that the zinc, there will be some deformation in my slide. So in the, if you just add these two half cell reaction, that is zinc is converted to the zinc 2 plus, this is an oxidation, this is called oxidation half cell reaction, and 2H plus is converted to the hydrogen by absorbing two electron, which is removed in the oxidation, that is and produce hydrogen gas. So ultimately there will be net reaction is 2H plus plus zinc is equal to zinc 2 plus plus hydrogen gas. So by means of this reaction one can get electricity. So now, yes, we are writing this Zn solid to 2H plus, and to produce the forward reaction. Now the reaction, if the reaction is happened, then we will get electricity. Now the question that whether this reaction will be happen or not. Yes, we know that the Gibbs free energy and other thing, but here we'll define a reaction, or the cell reaction will be successful or not can be done by measurement of the E, that is standard electrochemical potential, or here is the E cell, that means the potential of the whole cell. Since reactant and product are in their standard state, then we consider the E, or the potential for this cell is the standard potential. In that case we use E0 for the standard state, but in generally it is E, but for the standard state it is E0. And for in generally hydrogen electrode are considered as standard electrode, and its standard reduction potential, that is E0, is 0, and when the normality, or basically molarity of the H plus ion is 1 molar. Now for this zinc system, zinc to zinc 2 plus, the reduction potential is 0.76 volt. So there will be lots of reaction, and that is there will be lots of series, that is electrochemical series where the reduction potential is negative in case of lithium, potassium, etc., or sodium, but the reduction potential is positive. So if the reduction potential is positive, then it will be um, it will be undergo reduction, but if it is negative, then it will be oxidized. So if you think that zinc, here is if you consider the zinc, then it is 0.76. So that is a negative, so it will be undergo reduction, not oxidation. Sorry, again I am sorry. So that is the minus, so it is undergo oxidation, not reduction. So here the value of the reduction potential, here will be the chances of undergo reduction. So now we want to represent a cell, okay, by some notation. So here one cell can be represented by some lines. So in the first it is a solid, that is electrode, then aqueous solution, then there will be a salt bead, that is denoted by double line, double two parallel line, then again another chamber, that is aqueous solution, and then there will be a separation, that is a medium change, that is another solid, that is which is a electrode. So on the left hand side, basically we will place the thing of a cell which is acts as a anode, and in the right hand side the electrode is cathode. The single line defined phase, so single line basically electrode is solid but the solution is aqueous, so single line differentiate define between the defined phases, and double line produce the difference between the two solution, basically keep them separate, solve these. So these are the thing, and these are the batteries are galvanic cell, because this is a lead battery, and this is the representation of the lead battery. So and this is the ultimate reaction of the lead battery. The dry cell battery, those ways we are actually use as a battery, pencil battery, etc., and by using that we can get some light by using some bulb. Now electrolysis, I have already told you, that is the opposite of the galvanic cell concept or the voltaic cell, is the electrolysis. Now this is I am summarize this to remember or to make easy the study. Then oxidation, anode, so A is leading to the oxidation, and another case, that is cathode, obviously will be reduction. So always remember, anode mean oxidation and cathode mean reduction. So now here galvanic cell will be spontaneous and anode is negative, and electrolytic cell, obviously in electrolytic cell voltage should be applied, but in galvanic cell we will get voltage by means of the chemical reaction. So now here we will discuss about the another very important part of the electrochemistry, that is Nernst equation. By using Nernst equation we can say about the spontaneity of the reaction, and can get the cell potential in a defined condition, and etc. So and also by using this we can get the equilibrium constant at equilibrium of a particular reaction, lots of things. So Nernst equation is basically is derived from the Gibbs free energy under standard condition. So if I represent a cell potential in the standard condition, then E0 will be E0 reduction minus E0 oxidation. So basically here you can write that is E cathode minus E anode, because oxidation is at anode and reduction at cathode. So now del G is also related to the E by the equation del G is equal to minus NFE. So by combining 1 and 2, or very simply by using the standard condition, del G0 is equal to minus NFE0. Hence here in this equation f is constant, n is constant, and E0 must be E0 must be positive, and if it is a negative, then the reaction is non-spontaneous. From the thermodynamics, the Gibbs free energy change under the spontaneous will be question via. So we can write for a Gibbs free energy, that is del G equal to del G0 plus RT ln Q. Q is the reaction quotient. So now substituting the del G0 and other thing, so we can write that is minus NFE is equal to minus NFE0 plus RT ln Q. So here n is the number of the electron involved in the whole reaction, and Q is the reaction quotient, and F is the Faraday. So now dividing both sides by minus NF, we can get an equation that is E equal to E0 minus RT by NF ln Q. Now if you convert the ln to the log base 10, then the equation becomes like this. There is a mistake, it will be not ln, it will be log 10. So E equal to E0 minus 2.303 RT by NF log Q, not ln Q. Okay. So at standard condition, that is at 290 degree centigrade, 298 degree centigrade, that is at 25 degree centigrade. I am saying sorry, there is 298 Kelvin or 25 degree centigrade. This equation become E equal to E0 minus 0.059 RT it will be not like that, it will be 0.059 by n log Q. So there will be no RT, because by placing the value of RT and F, we will get this value, that is 0.0592. So now for an equilibrium, Q is equal to K equilibrium. So here del G is equal to 0, because in equilibrium that Gibbs free energy change will be 0. So del G is equal to minus NF0, so E equal to 0. So obviously here E equal to 0. Now if E equal to 0, then we can write 0 is equal to E0 minus 0.059 by n log K equilibrium. So please remove the RT, because we have already include the value of R and T. R is constant and T is considered 298 Kelvin. So please remove the RT from this equation. From this equation there is a mistake. So ultimately so 0.592 by n log K equilibrium will be equal to E0. Now if I know the E0 value, then we can calculate the K value. So by placing the K value, or by placing the E0 value, we can calculate K equilibrium, or that is opposite. So if K is greater than 1, then E0 will be greater than 0, then it is favor the reaction formation, that is it will be forward to the right hand direction. But if k is less than 1, then the log value will be negative, and in that case e0 will be less than 0. So that in that case, so or negative, in that case it will be non continuous or not a spontaneous reaction. So if I think about the E cathode and E anode, so last equation for the complete cell, if I apply this thing, so then E is equal to E cathode minus E anode, which is signed by E plus minus E anode. Now if the two terminal is attached, then there will be a cell potential E. So if the cell potential of the half is connected to the positive and the negative terminal, for in that case this type of the reaction, which is I have already discussed in the previous few in the first few two slide about the voltaic cell. In that case, if you consider the cathode, then standard reduction potential is 0.76 volt, and for hydrogen it is 0. So if we use zinc as a cathode and hydrogen, that is platinum, as a anode, then the cell potential will be 0.76 at standard condition. So as it is showing the positive, so del G will be, del G is equal to minus NF. NF is positive, and E cell for this case, that is in voltaic cell. So as it is the positive, so the del G value will be negative. So ultimately the cell will be worked. So this type of the cell will be work, and it will be give electricity. So student, thank you very much for your attention. Hope you will enjoy the class, and we are waiting, I am waiting for your question. Thank you very much, my dear student.